It cannot be A because normally isotopic mass should be a whole number, not fractional. This one is 63.5.
Okay.
No. Let me solve now before I come to that here. Yeah, let's solve this.
All
Let's
right.
solve this. Yeah, now let's do this. How do you find this? A out of the element. We want 3 times 112 plus 56 times 114 plus what?
41 times
41 times
5.
115. Everything over what? Over 100.
Okay.
So that in the way that you consider them, I don't make confusing. It should be 3 times 112, 56 times 114 plus 41 times 115 over 100. Can you, how do you get here? This is not weighted average mass. You can find the weighted average mass here. Is that okay? So what do you get here?
114.35.
4.
0.35.
What's the answer? Oh,
1.6.
4. Abi?
Mm-hmm.
One decimal place. A, D. Do you agree?
Yes.
Now let's do this again. Yeah, let's do this again. So this one is chemistry. It's an organic chemistry. I don't know why they put it here.
Okay.
Leave it. It's organic chemistry. It's an organic chemistry. Yeah, let's do this again. This one is also. You can do this one also. Yeah.
Sorry?
You can do this one also. Yeah. This is the mass. This is the mass.
Mass. Okay.
Percentage abundance. Yeah. What will we leave again? It will be what? 95.02 times 32 plus 0.76 times 3 plus 4.20 times what? Times 34 plus 0.02 times 36. Everything over what? Over 100. What is the total here is 100. Look at it. Total here is 100. So what do you get?
Just a second.
95. Let me also do it on my phone here.
I'm getting 32.09.
32.09.
Yes.
Exactly. And the answer is C. It's just a matter of mass times abundance. It's mass to charge. Is this
Okay.
this thing? It means mass to charge. It means what? Mass
The charge.
to charge ratio. And
Okay.
charge is equal to plus 1. What's not mass to charge? What was mass to charge? It should be charge. Am I right? It should be mass. But the charge is 1.
Mm-hmm.
The charge for charge, mass for charge means mass. Why? It's 1. Mass over charge means what? Mass. Why? The charge is 1. Do you get the point?
Yeah.
So that's how I calculate that. Mass charge means you don't take this as mass. Take this as your mass. They take you little abundance. That okay.
Mm-hmm.
Little abundance, and you get your answer. That okay. Now let's now go back to the one we said. The one we skip. Let's now come back now. So which one of you multiply gives CD5? It can't be this. The laptop cannot have fractional mass. Is that okay?
Mm-hmm. Yes.
So it happens to be whole number, so it can't be this. How you get this one? How we get this one now? So which one is likely to be the answer? Yeah. C may likely be. Yeah, let's try. What C? C is what? 74 times what?
63.
63 plus
26 times
6
65.
times 60. What do you get?
63.52.
That's just as well.
Okay. Also, I was supposed to calculate and then
Yes. Do the
okay.
one that when you calculate, you look at the one that would like them and don't calculate all of them. You waste your time in the exam. You can't calculate all of them. You waste your time. Just look at it
Okay.
now. 0.5. I know it's likely to be somewhere here. This one makes sense. But this one, most of the mass is so. I just thought that it was likely the one. If I do this
Mm-hmm.
and it's not the answer, I'll just leave it. I'll go and do it and I'll come back to it later. I will not waste my time on it because you have to be doing this one by one. Do you get?
Mm-hmm. Yes.
It's waste time and you don't want to waste your time. Do you get?
Mm-hmm.
So I think those are the one you didn't do. Let me see. Yeah, this one. Can't do this one now.
Which expression can be used?
What?
Oh, so we don't have to simplify it. It's 56.36 times 63 plus. So the first one is out, no? Can I see the other options? The first one is out. 25 10 65 18 over 100.
You three on top. You three on top. A
It's
is not
B.
correct. C is not correct. Is that the other is B?
So it's
Yeah,
B.
the C, so the other is B.
Mm-hmm.
You get it. So let me see another one. I did this. You mean some I corrected it too. You mean some I corrected. I've written the answer there. Don't go over
Okay.
there yourself. Then you didn't. What happened there?
Calculate the
You said
abundance.
this. You said find the percentage of all that to just add it together and move from 100 now. When did I get 0.0? It's not supposed to be 100 minus 99.76 plus 0.0.
Oh.
That's 100 minus 99 point. I don't know. 100 minus 99.80. Am I right?
Mm-hmm.
0.20. Why did you get 0.0 for?
Oh, I
That's
miscalculated.
mistake. The way when you calculate, you can't. If that makes sense. These two,
Mm-hmm.
you shall just try to use good calculator, please.
Okay.
This one, you didn't show okay though.
Oh, the last ones I ended up calculating on my paper because it was hard to type everything in.
Okay, I got the point. I got the point. I got the point. I got the point.
Yes.
I
Sorry,
got the point.
sir. I don't know. I think the volume, your volume looks, the voice looks a little bit muffled. So I don't know. Is it you're using earpiece or something?
The voice look what? It sound what?
Your voice, it looks a little bit like it's cracking. I don't know.
Even your as you're talking now.
Okay,
Hello.
so maybe it's my network
How
then.
is how is clear? Hello. Is my voice clear or not?
It's a bit muffled, dear, right? But I can still hear you.
How is my system? How is it? Because your voice is calculated too. So you say you lose voice also. How do you lose voice like? I don't know.
Okay.
I don't know. The network is very strong here. I don't know why. And I'm not using earpiece. I'm using my mouth. I'm not using earpiece.
Okay.
Okay, we could just manage it like that. It's fine, sir. Maybe it's my own. Yeah.
So and then sheet number 2, I know how to do the theory part of ionization, but now calculating and using the data sheet is quite difficult. I'm not understanding how I calculate the energy differences
You
and all that.
understand? Did you got my notes on the IE I sent to you? The note, have you gone over it?
Yes, I have.
Oh, that's fine. That's fine. That's fine. Because we skip it that time. We did do it. I just sent you the note. Let me look
Okay.
at the one. So one of this one I got the one you got wrong. I corrected them.
All right. I'll have a
I
look.
corrected them. I just sent you when I finish the class. Send it to you.
Okay.
Is that okay? Let me just save it now. So let me go and teach how to use data sheet now. Do you get?
Okay.
How do you define? Can you help me out? How do you define ionization? How do you define it? You don't divide. Just explain it to me. If you don't divide, just explain it to me or tell me what's your name about it.
Okay. So it's the energy required for an electron to be removed from 1 mole of an atom to
say that again. For an electron to be
it's
moved
the
from one atom. Are you sure?
sorry,
For an electron to be removed from one mole of an atom, is that what you said?
I said it's the energy needed to remove an electron from 1 mole of an atom of an element in
To
a
remove
in a
an
gaseous state.
to remove an electron from each of the atoms of gaseous atom. You are
Uh-huh.
removing the electron from each of the atom.
Okay.
How many atoms are in one mole? Put down. How many atoms are in one mole?
One,
Hello?
sir,
How many atoms are in one mole?
1 mole is equal
Oh,
to 1.602 times 10
aha,
to the power 23.
you are right, atoms. Each of these atoms is losing one mole. Each is losing one electron. Now listen, we do this. Beryllium gas. How many atoms are here? 6.02 10 to the power 23 atoms. So to now become this. No, to become this. How many ions are here? 6.02 10 to the power 23 univalent gaseous cation. How many electrons are here? 6.02 10 to the power 23 electrons. Do you get the point now?
Yes.
One of gaseous atoms, pay attention, each of them loses one electron. Each of the atoms is like you have how many eggs are in the crate?
12.
A crate of eggs. How many eggs are there?
6 or 12.
Okay, let's not use that one. That will not work. That will not work. Let's just say a dozen of human beings. Each of them loses one electron. A dozen of them consists of 12 people. Each
Mm-hmm.
of them loses one electron. So
Mm-hmm.
here now, one mole of gaseous atoms is here. Each of the atom loses one electron. Each of them loses one electron.
Mm-hmm.
So, so is the first IE, this is very well, is the energy required, right? To remove one electron from each atom in one mole of gaseous atoms to form gaseous ion. Can you see now?
Mm-hmm.
Each of the atom loses one electron. And you can remove one electron from each atom. It's very important. Look at it. From each atom. Each of the atom loses one. All of them loses one mole of electron. All of atoms there. Each of them loses one electron. Therefore, all the atom loses one mole of electron.
Mm-hmm.
How do you understand that? How many atoms are there? Samuna?
Sir,
How many atoms are there?
how many atoms are in
In one mole? How many atoms are here? How many atoms?
6.02 times 10 to the power 23?
Each of the atom loses one electron. Each of them loses one electron. Each of them.
Uh-huh.
So how many electrons will they lose?
Each of them lose 1 electron.
So all together, how many electrons will they lose altogether? 20.
6.02.
Thank you. They lose 1 mole of electron.
Mm-hmm.
Now let's this one. Look at another one.
Okay.
First IE is the energy required. Pay attention to remove 1 mole of electrons from 1 mole of gaseous atoms to form gaseous ions with +1 charge. Look at it. This is also correct. Which one do you prefer?
The first one.
Both of them are correct.
So,
You say to remove 1 mole of electron from 1 mole of gaseous atom to form +1. What does it mean to form +1 charge? Each of them must have lost 1 electron. You agree to that?
yes.
All of them form +1 charge.
Mm-hmm.
One of them is correct. You can say they are correct.
Okay.
First IE is the energy, is the enthalpy change. Enthalpy change to convert 1 mole of gaseous atoms to gaseous ions with +1 charge. Is it the same thing?
Mm-hmm.
They are all the same thing.
Yes.
Atom inside the 1 mole is losing 1 electron each. Let's say the number of people living in the whole world, let's say it's 1 mole. 1 mole people living in the whole world. Each of the person living the world 1 electron. Each person loses 1.
Mm-hmm.
We don't want the case. When you say you have 10 people, you have 10 people. So maybe 10 atoms. You now lose 10 electrons.
Mm-hmm.
And 8 of the atoms become +1. I mean, 6 of them become this, 2 of them become +2. Then 2 of them don't change at all. We don't want this case. We want each of them to lose electron. We want a case of lose more than 1. Why don't lose at all? We don't want that case. We want each of them to lose 1 electron. Is that okay?
Yes.
Good. So what are the factors influencing ionization energy?
The number of protons
Nuclear charge or proton number. Go on.
and then the distance of the how do I say it? The outermost shell from the nucleus.
That's correct. Or atomic radio. That's correct. We need to.
Uh-huh.
No, no,
And
shielding
then
effect. Shielding effect. Shielding effect.
shielding effect, yes.
How do they vary?
Sorry?
Nuclear charge or proton number. Nuclear charge or proton number. How does it vary? It is
The
proportional to IE.
okay.
The higher this guy, the higher, the higher. Do you get now? You
Okay.
know what that means?
Mm-hmm.
As yeah, where about distance?
Distance. It's inversely
I
proportional.
like that. I like that. And this guy is increasing, this
Better.
guy is decreasing. Is that
Mm-hmm.
correct?
Yes.
And finally, shielding effect is also inversely increasing, decreasing. Is that okay?
Yes.
Now, this is the factor now used to explain the trend of. I think I said, let me look at the note. I said, well, we have to be writing the notes. I just go by it. I want to go by before I keep class. Okay, since I've gone over it, let's just look at it together to save our
Okay.
time. 1 minute, please. It saves time. Since you have gone over, just go right now. I'm going to go to the third topic.
Okay.
Oh, God. Okay. Your classroom. Yeah. Okay. Where is the note? I think I sent the note to you. Yeah. I'm doing structure. Mm. Okay. The, the one on electrons in atom. No.
Atomic structure.
And there's one specially on ionization that I sent to you.
But it's in the atomic structure notes.
Okay. Is it right?
Atomic structure PDF.
Okay. Okay. Thank you. Thank you. Okay. 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 So applying these hidden factors now, how does the IE, how does it vary across the period? What's the trend of IE across period? Why is it increasing?
It's increasing because the number of shells is increasing, meaning that the distance is
Across
also increasing.
across the period, across the period, across the period,
Yes.
across the number of shares does not change.
Oh, it stays the same.
Do you agree? Do you understand that?
Yes.
Look at it. Lithium 2 1, beryllium 2 2, boron 2 3, carbon 2 4. Doesn't change. Is that okay?
Yes.
That go. So our nuclear charge is increasing across the period, right?
Mm-hmm.
What is the second point now?
Sorry.
What second? Look at the first point. Nuclear charge is increasing. What is the
Mm-hmm.
second point? It's
Shielding
front of
effect.
you.
Shielding effect is constant. That is, electrons
That
are
is
being added.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Agile Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, when this in 2026, when this is 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
For the same shell. You understand that? Do you
So could
understand that?
could you I did read the notes on shielding effect, but could you explain exactly what will be going on?
Okay. This is our sun. Sun.
Hmm.
This is Mercury, Venus, Earth. Which of the planets? This is our planet.
Hmm.
This is Venus. This is Mercury. Which of the planets is from the sun?
Which of the planet is what?
Which of the planet is shielding the Earth from the sun?
Mercury and Venus.
Thank you. So shielding means, shielding the French is, in this case, this is like a shell. Shell one, shell
Okay.
two, the third shell. Do you get the point now? So the more
Mm.
the shell you have, the greater shielding effect.
Mm-hmm.
Shielding effect is the ability to shield the nucleus from the attractive. Shielding effect is what? The effect
Okay.
shielding effect is the effect of shielding in what? An electron shell or electron shell from the nuclear pool from the nuclear pool, of course, of nucleus.
Mm-hmm.
That ability to shield means you are being shielded from it. Is that okay? So the
Yes.
so the more the shell, the greater the shielding effect. So shielding effect and number of shell, they mean the same thing.
Mm-hmm.
So why is shielding effect constant across the period?
Because the
Shell is
number of
constant.
shells is constant.
Exactly. The number
Mhm.
of shell, the greater shielding effect.
Okay.
Is that okay?
Yes.
Good. So now across the period, what can we say across the period? Nuclear charge increasing.
Mm-hmm.
That is constant. Nuclear pull on the shell is increasing. Therefore, distance decreases. Let me explain that to you. Look at it.
Okay.
Look at this. Lithium is plus 3, 3 proton plus 3. Beryllium is plus 4. Boron is plus 5. Carbon is plus 6. They all have the same number of shell. shell 1, shell 2, shell 1, shell 2, shell 1, shell 2, shell 1, shell 2. So the electrons here 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. The more the proton number inside the nucleus, the greater the pull, or the greater the what? The greater the proton number, called the nuclear charge, comma, the greater the pull, the greater the pull on electron shell, the lower the distance, the lower the distance. Can you see now? Of course, of outer shell, nucleus of outer shell. From where? From nucleus. So when I'm going across the number is, do you agree? That's nuclear charge. Point 1. Are you there?
Mm-hmm.
Point 2. The threat is constant.
Sorry, it's not clear. Are you asking a question?
No, I'm telling you why there is a decrease, increase in IE across the period. Why there's a decrease in IE across the period. Number 1, across the period,
Mm-hmm.
what can you say about nuclear charge?
The nuclear charge is increasing.
Nuclear charge increases. What else again?
The electron pull is also greater.
Shielding effect is constant. There are 3 factors that influence IE. You
Mm-hmm.
must mention 3 factors in your argument, your presentation. The
Okay.
3 factors are nuclear charge, followed by shielding effect, then distance. Am I right? Keep the 3 factors in your mind. So across the period here, nuclear charge is increasing. That's point 1. Nuclear charge means proton number.
Mm-hmm.
Nuclear charge is increasing. Is that settled?
Yes.
But shielding effect is constant. Is that correct?
Yes.
Then now, what happened to nuclear pool? The nuclear pool, this one. What nuclear pool? Nuclear pool, this one. What happened to?
It increases.
Why is it increasing? Because of the number of increasing proton. A number of shell does not change. Nuclear pool decreases, therefore distance decreases. Nuclear pool, so point 2. So I say number 1, nuclear charge increases.
Mm-hmm.
Number 2, shielding effect is constant. Number 3, nuclear pull or attraction on outer electron shell does what? Increases.
Mm-hmm.
Therefore, distance. Right? Therefore, what happened? Therefore, distance of outer of outer shell from nucleus decreases. Is that okay? Decreases.
Mm-hmm.
So based on this C factor, what should happen to IE?
So the ionization is also supposed to increase.
Why? Let's take it one by one. Look at the get to point to, because I need to be sure you understand this.
Okay.
Let's take it one by one. Now, based on the increase in nuclear charge, what should happen to IE?
So
Remember,
because
nuclear charge increases, I also increases. Do you agree?
mm-hmm,
What's my second point? Shield effect is constant, so it has no say. Shield effect has no effect. Am I right?
mm-hmm,
But it's constant, so no effect. Now, what look at the second third point? Nuclear pull on outer electron shell increases. Therefore, distance
decreases.
distance is what?
It's decreasing.
Thank you. What would happen to as distance is decreasing, I should increase. Do you agree?
I agree.
So can you see the theory now? So overall, I should increase. The effect factor, which is nuclear charge, says as increasing, I should increase. We say okay, no problem. Second factor say me have constant, have no effect on IE. So shading effect has no effect on IE across the period.
Okay.
Point three now, as distance is decreasing, I should increase. Summarily, ionization energy increases across the world.
The period.
You agree, John?
Yes.
So three factor, don't forget, nuclear charge is increasing. Shading effect has no is constant, but distance is decreasing due to nuclear pull.
Mm-hmm.
So somebody I should increase across the period, right? What
Yes.
about that the group? Can you read?
The shielding effect on number of shells increases. The
So based on
distance.
that, no. Based on that, what should happen to IE? Based on that alone, there's an increase in shielding effect. What should happen to IE?
It should decrease.
Thank you. Thank you so much. I like that. I like that. We keep that. Yeah. Next one.
Distance of outer electron from nuclear increases.
What should happen? Based on that alone, what should happen to IE?
Distance of outer electron
The
increase.
distance is increasing.
So the ionization energy decreases.
Thank you. So two factors are saying that IE was. Now let's see the factor.
The third factor,
Go on. Read the third point.
nuclear pull on electron shell decreases.
Go on.
Ionization energy decreases despite an increase in nuclear charge because the combined effect of shielding effect and distance outweighs the effect of nuclear charge.
Do you get the concept? Down the
Uh-huh.
there's an increase in nuclear charge down the group, but nuclear charge, though it's increasing, but it doesn't have effect. You know why? The two other factors combined together avoid the effect of nuclear charge. Do you agree to that?
Yes.
Good. So therefore, down the group, it decreases despite an increase in nuclear charge because the combined effect of shielding effect and distance outweigh the effect of what? Of nuclear charge. Is that okay?
Yes.
Now, this is now you can now see that it's increasing. Can you see now? It's increasing from what? From lithium to neon or from sodium to what? To argon. Questions along the line. Hello?
Sir?
And there are some fluctuations along the line. As it's increasing down the group, it's increasing that way. Do we have some fluctuations along the line? Hold
Along.
on.
Okay.
Okay. One minute, please. Let me download this.
Okay.
I couldn't write. I want to write on it. I couldn't write on it.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ijel Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at agiotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at agile@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Yeah, I say, thank God. Mahmoud, are you with me, please?
Yes, I am.
If you say IE is increasing across period, I want to draw the IE of the first of the element same period for me. How should the graph look like?
For which element?
Maybe sodium, maybe from sodium to argon. Look, it should be like this now, straight in line now. It's increasing.
Mm-hmm.
It should be like this. All right. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, or lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's how it should be now. You say it's increasing across period. Is that not so?
Mm-hmm.
Element in the same period, it should be increasing from sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Is that correct?
Yes, sir.
Now look at it now. Look at the graph now? Is it really increasing or not? It's increasing. But there's some fluctuations along the line.
Mm-hmm.
Which element to which element from which and which? This is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, or sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Some fluctuations along the line.
Pardon?
And there are some fluctuations along the lines. It's supposed to be increasing like this. It's increasing truly, but there are some fluctuations along the line. Is that correct?
Yes.
Between which element and which element?
Um, do I also have to refer to my periodic table?
No, no, no. From this graph, from this graph. I'll show you the
Between
first one. No, look at it. What I'm saying is let me explain to you the better way you understand that. I think my head. Okay, look, come and see this. I open this twice. Let me write something for you. Yeah, look at it now. Look at it, please. This lithium, beryllium, boron, carbon, nitrogen, oxygen, carbon, nitrogen, oxygen, fluorine, neon. Are you there? So this
yes.
is first IE. How should it be? This guy should be like this. Right? Higher, right? Higher
Mm-hmm.
still, higher, higher, higher. Should be a straight line. Am I right? That's what I'm saying.
Mm-hmm.
But is it exactly a straight line? Is it exactly a straight line?
No, it's not.
Where do we have fluctuations? Between the
Between
element and which element?
B what's this? Beryllium and boron.
When we are talking, we are going and which element again?
Between nitrogen and oxygen.
When we are talking, now I'm asking you now. When we are talking now. So
Mm-hmm.
it's supposed to be like this. Normally, it's supposed to be like this, normally. Straight line. But it was not like, look at it, it was not like this. So like this, lithium, beryllium. Something to be boron. Now it came back to boron a little bit. It came down. It didn't go up. So that boron is now lower than beryllium. Because the boron coming down. I say, why now? Then I go back to carbon, nitrogen. Oxygen also came down. Why now? The fluorine, the neon. So there's an anomaly here.
Mm-hmm.
Between there and here, between there and there. Do you agree?
Yes.
Going from beryllium to boron is supposed to decrease. Is that okay?
Mm-hmm.
Then nitrogen to oxygen is supposed to increase. It also decreases. Do you get that?
Yes, sir.
Why that fluctuation? Why? That's the question we're asking. Why? Why is a 5 proton? How come it's one and boron with a 4 proton? Why is oxygen with 8 nuclear charge as a number? No one has one of 7. How come? The same thing is also observed in the following period, as in sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Either between these two, also between these two. Are you there?
Yes.
Between these two, also between these two. Can you see that? You follow a following number. Hold on. The next time I cannot confirm this to you by what now? By your data booklet. Are you there with me?
Uh-huh.
Open a data book to put you that what I just said now is correct. Now, if you have a copy of data booklet, which I've sent to you already. Let me actually show you how we can put that. What I said now is correct. This is your data booklet. Now look at it.
Okay.
They supply the first 4 IE. Now, beryllium is 900. First IE of beryllium is what? 900 kilojoule per mole. What about boron?
799.
It drops. It increases. It drops. Don't forget that lithium to neon, they are in the same period. Don't forget. This guy in the same period.
Mm-hmm.
This guy also in the same period.
Yes.
So now we are going from based on what you said, from lithium to they're supposed to be increasing like that without any stopping. Is that okay?
Mm-hmm.
But it came down here. So between these two, there's a problem. Then between
Mm-hmm.
these two also, there's a problem. Is that okay?
Mm-hmm. Yes.
And again, in periodic, between these two, there's
There's
a
a
problem. And between these two, there's a problem. Is that okay? So always
yes.
between what? Between always between groups. So between what? Groups 2 and 3 and 5 and 6. Groups 2 and 3. Either base, boron, or magnesium and aluminium. 5 and 6. Either nitrogen and oxygen or phosphorus and sulfur. Is that okay? There's a
Yes.
fluctuation somewhere there. How do we account for these anomalies? How do we account for these fluctuations? Let's go back to the note. It's in the note. Can you read this, please?
Outer
Yes.
elect. Sorry.
Yeah. I'm saying that first IE of boron is less than first IE of beryllium. Is that okay? Go on.
Yes. Then outer electron in boron is on p sublevel, while that of beryllium is located on the s sublevel.
Okay.
P
Go on.
orbital is more distant from nucleus than s orbital.
Did you get better?
Yes.
Because that p orbital has more energy, therefore it's more distant. Let me say that to you. This beryllium, 4 proton beryllium, first shell, second shell, 2s closer. Look at boron. First shell, second shell. Can you see that?
Mm.
Which electron? This is beryllium number 4, and it is 1s2, 2s2. This guy is boron number 5, and it's 1s2, 2s2, 2p1. Which of the, I mean, which electron are we removing from beryllium?
Pardon?
Which electron do we want to remove from beryllium? Which electron? We want to remove this guy to be removed. Am I right? What about this guy? This one to be removed, right?
Yes.
In beryllium, we are removing 2s electron. In
Mm-hmm.
boron, 2p electron. Is that okay?
Yes.
Now look at the distance now. Look at the distance. This guy very far from the nucleus. This guy
Closer to the
very
nucleus.
close to the nucleus. So this also the answer is this. After electron in beryllium is to be removed from an s subshell. That of boron is from the p subshell.
Mm-hmm.
Electron of p orbital is more distant and it's at higher energy. It will be removed. Is that okay?
Yes.
Electron of p orbital is one of the nucleus. Uh, So the p orbital is at higher energy. P orbital is at, is that okay? P
Yes.
orbital is at higher energy than s orbital. Therefore, it will be p orbital. Is that okay?
Mm-hmm.
The same argument goes for magnesium and aluminium. For magnesium, it's still the same thing again as aluminium. Magnesium again, it just is 1s2, 2s2, 2 pieces, 3s2 on s subshell. Aluminium, 1s2, 2s2, this is 3s2, 3p1. Again, in magnesium, it is 2s2. I mean, 3s2 here it is 3p1.
3p1.
So that the p subshell is higher energy. Therefore, it is more distant from the nucleus,
Mm-hmm.
and hence can easily be removed. Is that okay?
Yes.
Good. That's about that. You understand that now? So there are
Mm-hmm.
two. There is. I'm explaining this now. I'm explaining this now. Explain this now. The evolution is about nitrogen and oxygen. Nitrogen is what? 1s2, 2s2, 2p3. What does it mean? 2px1, 2py1, 2pz1. Is that okay?
Mm-hmm.
What about oxygen? What does it mean? What does this mean? 2px2, 2py1, 2pz1. Is that okay?
Mm-hmm.
Look at the hydrogen atom. One, 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 one. They are stable.
Pardon?
The electrons here, they are
Yes.
all singly occupied. They have one electron of the orbital. So this is symmetrical.
Yes.
One. Here, we have electron pair repulsion. The p orbitals, they are symmetrical. They are okay. But
Mm-hmm.
oxygen, two of them, is that okay?
Mm-hmm.
I don't feel like this. That's for when I was teaching you atomic structure.
So
Something like this.
it's not clear.
What I'm saying is not clear, right?
It was breaking. It's now fine.
So what I'm saying is that if you have a P3 system,
Mm-hmm.
it's a symmetrical system. They all have one.
Yes.
But P4 is not symmetrical. One of the orbitals has two electrons.
Mm-hmm.
Therefore, the two electrons here will be this here. We are called electron pair repulsion. They will be repelling themselves.
Uh-huh.
So it will be easier to move electron from P3. P4 and P3. In P3, they are all one.
Mm-hmm.
If P4 one of them is 2, so they can easily lose electron that losing one of P3. Is that okay?
Yes.
Which of the P element is symmetrical? Which of them is symmetrical? We say P3 and P6. They are
Symmetrical.
symmetrical. Do you remember this?
Yes.
What about P6? Very stable. It's for the noble gases. What
Mm-hmm.
about P5? Strong oxidizing agent. Can you see one electron? Is that okay?
Mm-hmm.
And P what now? And then P4, we have
It's
this.
reducing
1, 2, 3, 4. Here, what happened there?
electron
Electron pair
repulsion.
repulsion. They repel themselves.
Mm-hmm.
Electron uh, electron pair repulsion. Electron pair repulsion, of course, here. Is that okay? Electron pair repulsion, of course, is that okay? If
Yes.
P3 and P6 are symmetrical, P3 is very stable. P5 is a strong oxidizing agent. And P6 and P4 is a what? It's an electron pair repulsion. So the same thing
Mm-hmm.
goes for nitrogen and oxygen. Nitrogen p orbitals are 1. They are stable, they are symmetrical. Oxygen is 2. Okay.
Yes, sir.
So you know the reason that why nitrogen is higher now. What's the reason I put it in your note? Read it for me now. Why lower than air? Can you read? Yeah.
P orbitals. P
Yeah.
orbitals in nitrogen atom are half or singly filled, hence they're symmetrical. And then electron pair repulsion occurs in one of the p orbitals in oxygen.
Do you understand the question?
Yes.
Thank you so much. Finally, successive I values. How do you know the group an element belongs to when you see the values? Look at this. Mm, I think the textbook I share with you. Is it here? The textbook I share with you. Okay. Let me just use that booklet. Now look at it. Suppose we don't know the group it belongs to. We don't know. Look at magnesium. What's the first I of magnesium?
736.
Abi,
736.
what's magnesium? First I of magnesium. 736.
Mm-hmm.
Second IE.
1450.
1150. What about third I? What about third?
7740.
Now, from here to here, how many times? How many times? Like two
We
times, right? Is that correct?
yes.
736 times 2. I have finished something. It's about 2 times. Is that okay?
Yes.
What about here? How many times?
It's about 5 times.
Thank you. This one come 7,000 to 10,000. About 1.5 times. Am I right?
Yes.
So when you have a big jump in this, when you have a big jump in the values between the second and the third value. You have a
Yes.
between the second and the third. What does this mean? The third electron is taken from a different shell.
Mm-hmm.
From an inner shell, you be from another. Remember what that means is look at this. To remove the first electron, what's the value? 736. Second one, 1,460. Third one has to be another electron. What is a big jump? What is a big jump in the value? It means that you are is that okay?
Yes,
Now let me
sir.
give you a black down so that I can let me give you a value down. Make sense of A, B, C, D. IE values. IE. First, second, third, fourth, fifth, sixth, 742. 1,000, 4,300, 9,000, 17,100,
Mm-hmm.
940, 2,000, 2,000, 3,980, 12,000, 19,000. Let's do this two first of all. A big jump between the for A. Where do the big
The
jump
big
occur?
the big jump is between the third and the fourth, meaning that that's now another shell. They're removing an electron from another shell.
I'm not sure that's correct. I'm not sure that's correct. How many times? For me, how many times?
And let me calculate.
It's
17.
less than 2 times. There 2 times. Where by here? It's about 2 times also. Where by here? It's about close to 6 times.
Oh, okay.
We're looking at the arithmetic, we're at the geometric increase, not the arithmetic increase, not by saying it's about how many times does it, how many times does it, how many times, not just by how much does it increase. How many times
Okay.
has increased?
Mm-hmm.
740 to 4,300 is about 6 times. So this guy's a
Mm-hmm.
group one, group one. Now the second electron was removed from a different shell. Can you
Okay.
try number 2? Number B.
Between first and second, it increases. It's times 2.
About times 2. About times 2.
Mm-hmm.
About times 3.
Yes, and then
About times 1.5. So the other is,
yes,
which group is that?
group 3.
Group 3. Is that okay?
Yes,
So look at it very well. I'm sure you don't make mistake in that. I'm sure that makes sense.
yes, it does.
Good. So I think I'm done with this. Is that okay?
Mm-hmm.
I'll just say that. You guys want to still go over this. This is, I'm going to combine topic that I've not taught you together with this to teach this topic here. Now look at, I told you there, say find this. Say look at this, say find enthalpy change, energy change for the reaction. Number 1, Mg to Mg gas become Mg2 plus gas plus 2E minus. What does this mean?
A second ionization.
It's not second, it's first one. First is Mg to Mg plus. Now this one means I both of them together now. Is that okay?
Sir, could you
Mg to
please, sir?
this one is first and second.
Okay.
Do you agree?
Yes.
So there will be the energy that you just what? First IE coming plus what? Second IE. Just copy the value. Yeah.
Mm-hmm.
What is your 736 4050? 736 4050. That's the answer. Okay.
Yeah.
Kilojoule per mole. Okay.
Yes, that's 2,186.
Okay. That's
Yes.
good. What about what did we give you this? Hold on. Okay, what did we give you this? No. Before that, they give you this 2Cl gas, 2Cl plus gas plus 2E. What does this mean? When you got the
That's
two,
the
move the two, remove the two. What is this?
first ionization energy.
Thank you. Now put the two. What is it? What just that? 2 times first.
Oh, okay.
Is that okay? Or they
Yes.
put two there. Chlorine is what?
1260.
F6.
1260 times 2.
Hold on. Yeah, it's 1260. The 2 times 1260
That's
plus 1520 kilojoule per mole. Am I right? Are you there?
how did we get the plus 1,520?
12, it's not correct. I'm sorry.
Oh,
What,
oh,
what is
yeah, it's 2,520.
2520? Sorry.
Okay.
Kilojoule per mole. Is that okay?
Yes.
You know the common endothermic and endothermic reaction.
Sir?
What they call endothermic and exothermic reaction.
Yes.
So ionization energy is an endothermic process.
Okay.
So it is energy required, energy absorbed. So it is always plus. It's the
Okay.
energy required to do something, energy absorbed to do something down. So it is always endothermic. So delta H is plus. Okay,
Yes, that's fine.
thank you. Now, I'm going for that now. Look at this. Cl2 to become 2Cl plus 2E minus. How do we do this? Here, let me tell you what they do. Step 1, they first broke chlorine to become 2 chlorine like this. Is that okay?
Yes.
Step 2, they now do 2 chlorine to now become 2 chlorine plus 2 electron. Do you get it? The
Mm-hmm.
first broke the molecule. Cells usually say molecule. Broke the molecule in what? First of all. And now convert the atoms to ions. So how do we break the molecule? Come and see this. We call it bond energy value. Look at it. Chlorine, chlorine. What's 42? And if you convert Cl to Cl and Cl is what? 242.
Okay.
So I'm going to do this plus 242. Then this is now 2 times first IE. You got that to be what? 25, 20. Am I right?
Mm-hmm. Plus 242. So 2762.
How do you get that? 2 what?
2762.
Kilojoule per mole. Is that what?
Yes.
Why did I give you this? Why did I give you this? It's a bit tricky. You have to be careful here. What do you think I'm doing here? I can convert this first, convert it to what? 2O gas. Am I right?
Yes, to give
They convert this
2
to what?
oxygen.
2O plus 2 electron. Then to this
Mm.
now. Now let's do it. Which one is this? Break the oxygen to 2. Look at it. That's OO.
Oh, oh, 496.
496.
Yes, 496.
Yes. This is 496. What is the second one? First, ionization energy times 2. Is that okay?
Yes.
Let's go and see OO. What are you looking for? First IE. Oh, yeah, let's go. 1400.
1310.
So 2 times 1400. It's 1400. Oh, one, oh, 1310. Sorry.
1310.
Thank you. 1310. Lastly, what about this? This is second, 2 times second IE, right? And
Mm-hmm.
that's what they mean involved. 3390.
3390. Yes, the second ionization energy. Yes. So are you speaking? Okay.
Can you hear me?
Yes, I can.
Just 1 minute, please. Just 1 minute.
Okay.
So, so the first one is this is bond energy. This one now. So what's the answer to this guy now? Now look at it. This is mathematics. This is logical. It's going to go like this. You then went this way. This is A. This is B. This is C. This is D. How do we connect them together? A should be equal to what? B plus C plus D. Do you agree?
B plus C plus D. Which one is
So,
D? The one going up.
oh, what's up?
Okay. Yes. So it's 49496 plus 2 times 1320 plus
1320.
2 times
times
3.90. I'm
what is the
getting,
second IE of oxygen? 3.30, yeah.
yeah, I'm getting 9916.
9 what?
9916.
Kilojoule per mole. That's the answer for that
Yeah.
reaction.
Mhm.
Because they consider all of them together. No, we're not talking about this one in chapter 5, but this is how they do it.
Okay.
You see, we are not talking about this one in chapter 5 in chapter 5.
All right.
You might have to change better. Do you get the point?
Yes.
We have to do it better. This is how to, for now. Do you get?
Yes.
But if you now say, what if you do this? What about this? How do you find the enthalpy change? The enthalpy.
So that's first ionization energy plus second. 3 plus third ionization energy.
Which one is this? So tell me. Oh.
It's the first, second, and third ionization energy.
No. Electrons involved. It's only 2 of them, not 3. There are 2 electrons involved. Come with 3.
So
It is
it's
first, second, and third. You involve 3 electrons.
okay.
These are involved only 2 electrons. So there are only 2 of them here. Which and which?
So it's the first and the second.
No. First is Al to Al plus. First is what? Al to Al plus electron. What about second? Al plus to Al2 plus E. What about the third? Al2 plus to Al3 plus E. So what is this?
Okay.
First is Al plus. Is there Al here? Is there Al?
Sorry?
Is there Al? First is Al. First will start from Al. Is there Al in this equation?
No, there's Al plus.
Is there you didn't answer my question. Is there Al in this equation they gave us?
No.
Then
No.
the first part of it, then you guys saw part of it. Simple.
Okay.
Because start from here, there's no Al here. The Al is taken out of it. So there's no part of it.
Oh, okay.
So which one is this now?
The
If it was
second.
second and third.
Oh, okay.
Can I prove it to you? Let me sum it up. Yeah, look at it. Let me sum it up. Second, can I sum it up? You add them
Yes.
together. Can you add them together?
Al3 plus.
Hold on. Hold on, this cancel this. They are the same.
Mm-hmm.
What will be the answer?
Al
AF plus to give what?
3 plus
Plus how
2E.
many electrons? 3 electrons. Is that the same
Yeah.
thing?
Yes, it is.
You get? So this one is what? Second and third. It's not, there's no first there.
Oh, okay.
It's second and third. There's no first there. First will start from AL. Is that okay? Yeah, I'll do
Yes.
this for me. Yeah. Which one is first for silicon? Which one is first for silicon? Silicon is what? Si to Si plus. That's first. Is there Si here? No, it's not there.
Mm-hmm.
This is first. Well, we on the second. Si plus to Si2 plus electron. Is there Si2 plus here?
No.
Here we did produce, we start from Si2 plus.
Mm-hmm.
Si2 plus as a reactant to Si3 plus. Si2 plus is there as a reactant.
Yes.
Third. Then Si3 plus to Si4 plus. Si4 plus is there, so it includes this and this. You agree?
Yes, I agree.
So which one is there? Therefore, third and fourth.
Okay.
First is from Si to Si plus. Si plus is not here. Second is Si plus to Si2 plus as a product. Si plus is a reactant, it's not there. It Maria, do magnesium for me. First ion of magnesium. The first ion. Second.
Mm-hmm.
You understand it?
Mm-hmm.
And third. And fourth. Is that okay?
Yes.
First, second, third, fourth. Is that okay?
Yes, sir.
If I now do this now, which I is this? Yeah, second. Yeah. Which one is A? Which one is B? We are going.
A
A is
is
what?
the second, third, and the fourth.
Now you are talking. Now you are talking. Second, third, and fourth together. What about B?
B is first, second, and third.
Now you are talking. Now you are talking. First, second, and third. Listen up. Doesn't make some sense.
Mm-hmm. Yes.
You just have to practice. Understand it. Am I right?
Mm-hmm.
Good. If practice what you it's not difficult. Then you have to have this kind of thing in your mind. Have this one in your mind. You don't have to write down. You have to be in your mind. You
Okay.
can extract from your mind that is that
All
okay?
right. Yes, sir.
That's okay. That's okay for you. So finally, if they give you a graph of one single element, look at this element. Number of electrons removed. Energy required. Number one, number two, number three, number four, number five, number six, number seven, number eight, number nine, number 10, number 11, number 12. This is for magnesium. Look at it. The first one, how many electrons does it have? Magnesium is 12, right? It is 282. Is that correct?
Yes.
2 outer electron, 8 middle electron, 2 inner electron. Do you agree?
Mm-hmm.
So how do they go magnesium? Look at the first I, it will not be very high. Second will not be very high. Third will be very higher. Jump. And
Okay.
you
Yeah.
jump. Because the third one is taken from an outer shell. It jumps. You have taken care of this one. Like next 8.
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8.
Then the
The next
jump.
8 will increase it. Then now to go inside jump again. Am I right?
Mm-hmm.
Jump and jump. So this guy was belong to group 2. This outer electron, the first 2 are the outer. How you know? These 2. Maybe I should do aluminium. Okay, this is the outer what shell. Middle what? Shell. And the guy is what? Inner shell. Inner shell. Do you get the point?
Yes.
So you have the first jump. The first jump tells you the first jump. The second jump, am I right?
Mm-hmm. Then the second.
First jump, I call it like that. The first jump tells you the group. Is that okay?
Mm-hmm.
So nitrogen is a group 5 element. Where do you expect a jump in these consecutive ionization energy values? Where do you
Which
expect
element?
a jump? Nitrogen is a group 5 element. Nitrogen is a group 5 element. Where do you expect a jump to occur? In the consecutive ionization energy values of nitrogen.
Nitrogen. Nitrogen is in group
It's a
5.
group 5 element. Yeah, group 5 element.
So at five there's going to be a jump after all the 5 electrons have been removed. There's going to be a jump between 5 and 6.
Between the 5th and the 6th IE value. Maybe jump between the 5th and
And
the
this,
6th IE value. Do you get that?
yes.
That's not to say that. I think we are done with that. So I'm done with this stuff. And I have some more questions. And you can get it right. Exactly. And now you can also try your end of chapter. The I sent to you. The textbook you have, are you there?
Yes, sir.
You can try end of the chapter question. The answer at the back.
Mm-hmm. Yes, also there are also questions on ionization on the worksheets you sent. I'll also do those.
That you don't understand. Now you should be able to understand them now, right?
Mm-hmm.
Good. So try them. I'm just saying that even your textbook contain topical questions. After I sent you the software. I mean, the textbook. I haven't read it.
Sorry?
I sent you a textbook on your classroom, a Google classroom. A
Yes,
copy
I
of a
said.
textbook.
Yes,
Download
sir.
it. After each chapter, there are questions at the end of the chapter to solve for you.
Okay.
And the answers are at the back. You can check the answer yourself. They are at the back at the end of the back.
Okay.
Do you get that?
Yes, sir.
There are questions. Are you there now?
Mm-hmm.
At the end of the chapter question, there are questions that you can solve. And the
Okay.
answers to them at the back of the textbook, the soft copy I posted online. The answers are at the back of the textbook. You can check your answers. If you don't get, you can now let discuss it.
Yes, sir.